Mark P. Otten back with you. All right, a quick video to show you a analysis of covariance ANCOVA for when you have one independent variable and that independent variable has dependent samples. So a one-way dependent samples ANCOVA, building on our one-way dependent samples ANOVA that we did in an earlier video where we sampled for social. I laugh because sometimes my examples are just, I don't know, they're a little too silly. This one's a little too silly, but this is real. I mean, it's based on like a real line of research that talks about social anxiety and familiarity. And if you become more familiar with a face over time, perhaps it becomes less threatening. So we sampled 4 adults in this hypothetical experiment. We showed them a picture, and then we sampled again after a few weeks, and we showed them this picture again, and then a third time we showed them this picture, and we asked them about threat, how threatened they felt by it. All right. Anyway, that was Barney. Our conclusion was that there was a difference. Actually, people did, according to the numbers, their perceived threat ratings went down across the 3 time points, which was pretty. It was a pretty big change, given that there were only 4 people. It came out to be significant. Of course, in real research, you'd want a larger sample, but. Suppose, in this case, we added in a covariate, and I'm just going to add in gender. We're hypothesizing, is there a difference now in perceived threat across time, controlling for gender? And so we're going to declare 2 of our participants as male, 2 of our participants as female. Of course, there are more gender denominations than that, but we only have 4 people, and that's what we're going to use. So let's show you the SPSS data. All right, so here is the data in SPSS. We've got time 1, time 2, time 3. That's just your, we've already analyzed this data. This is just your 3 time points. We did an ANOVA in a different video to show that, yes, there was a difference going across time here in perceived threat score. Generally, these scores are going down from time 1 to time 2 to time 3. Now we're just adding in 1 additional column for the covariate. Covariate is gender. Participants 1 and 2 are male. They get a 2. Participants 3 and 4 are female, and they get 1s. So relatively straightforward in the data entry here. We're just going to go to Analyze and General Linear Model and Repeated Measures to analyze. Now this is the same place we went for a ANOVA, in this case, Dependent Samples ANOVA. Now we're going to go here for the ANCOVA. So I've already run this, so I'm going to remove things and then redo it real quick for you. So this is your time independent variable with 3 levels. So you're just going to name it here. Within subject factor name would be time, 3 levels. You're going to hit add. It's going to load it into the box below. That's all you do. You ignore the covariate at this step. And then again, I'm going to move this back over to where it should appear for you on the left side. Okay, so this is what it will look like for you on the left side. You're going to start with the independent variable again, move time 1, time 2, time 3 over to the within subjects variables list, and since they're in order here, you can keep them in order and just move them directly. And then the covariate remains. The covariate goes into the covariate slot. Now, if you moved it into the between subjects factor slot, you'd get some analysis. What would that be? That would be treating the covariate as an independent variable, and it would actually be a mixed ANOVA now, mixed 2-way ANOVA, instead of in this case, 1-way ANCOVA. So we're going to keep it here. What's the decision there? Well, you just go back to your hypothesis. In this case, our hypothesis is that there is a change over time while controlling for gender. And so our focus is more on the independent variable of time. So you just translate your hypothesis as closely as you can to your analysis, and it's no different here. So, okay, we could do more with the statistics here, but I'm just going to click through, keep it simple for you, or relatively simple anyway. And then you get your output, gives you a bunch of stuff. Let's go to tests of within subjects effects. This is where the main stuff is. And you've got a non-significant effect now. So before, when we did the ANOVA without the covariate, we got a significant effect. Perceived threat was decreasing over time significantly. Now it's not. So now controlling for gender, there is no significant effect of time on perceived threat scores. I know that because the p-value is 0.125. greater than 0.05, F value 3.66. That first line, you can use that first line there, sphericity assumed. So the interpretation can get interesting here because it looks like the covariate is indeed having an effect of some kind. Technically, you would just say there is no effect of time while controlling for gender, or no significant effect of time while controlling for gender. Generally, what this means now is that the covariate and the independent variable have some sort of relationship that's interesting. In this case, gender and time. So if we look back at the data, we're going to see, like, what does this look like? It looks like the females are actually decreasing a little bit faster than the males, right? The participant number 4 there, 7 followed by 1 and 1. The males are decreasing, but maybe not quite as much. So it looks like gender is a factor here. And that's really all you would say, besides the fact that now our effect is not significant. There's one supplemental thing that we like to look at here as well. Tests of between subjects effects. You can look at the direct effect of gender on satisfaction. So we've got a 0.106 p-value for this supplemental result. This is greater than 0.05, so there's no direct effect of gender. There's no relationship between gender and satisfaction directly. And that's it.